Good day. I welcome you at the current lecture on numerical problem solving of analysis of cables of the subject Structural Analysis 1. The subject code is CEPC 503 and the related module number is 2. Myself, Sandeepan Saha, Assistant Professor for the Department of Civil Engineering of Greater Kolkata College of Engineering and Management under GIS Group. Let us first have a look on the topics that we are going to cover in this lecture. So in this lecture, we will be doing some numerical examples in order to understand the mechanics of cable. That means the cable suspension bridge. So let us draw a problem on cable analysis. And this is the problem. A light cable is supported at 2 points 20 meters apart from which are at the same level. That means we're talking about these 2 points. That is, the distance between A and B is 20 meters and they are at same level. The cable supports 3 concentrated loads. That is 1, 2, 3, and those are 40 kilonewton, 30 kilonewton and 20 kilonewton respectively. The deflection at the first point is found to be 0.8 meter. That is this. The point under the first load gets deflected by 0.8 meter. Now we have to determine the tension at different segments and the total length of the cable. So as you can see, the following vertical reactions at support A and B are VA and VB, and the horizontal thrust at A and B are H. So now we have to calculate the tension at different segments and the total length of the cable. To solve this problem, first we need to calculate the reactions at point A and B, that is VB and VA. So to do so, taking moment about point A, we have the total summation of the moment is 0. So about point A, we have the moments, and those are 40 multiplied by 5, then 30 multiplied by 10. The next moment is 20 multiplied by 15, and the next moment is due to the force, there is a reaction force VB multiplied by 20. Now we have to calculate we have to determine the sign convention. Taking anti-clockwise moments as negative and clockwise moments as positive, we have this is positive, this is positive, this is also positive, this moment is also positive, but this one is negative. So after calculation, we get VB equals to as 40 kilonewton. As we can see that at the given problem, the total of VA and VB is 90 kilonewton. So from this, we get VA equals to 50 kilonewton. Now we have to calculate the beam moments at points 1, 2 and 3. That means the point 1 is here, that is under the first load, that is under the 40 kilonewton load. The second point is under 30 kilonewton load, and the third point is under 20 kilonewton load. So the moment about point 1, that is M1, equals to VA multiplied by the distance between point 1 and the force VA, that is 5. So we have calculated VA as 50 kilonewton multiplied by 5. We get M1, that is about point 1. The moment is 250 kilonewton meter, followed by the moment about point 2, that is M2 equals to VA multiplied by 10 minus 40, that means moment due to this force, 40 multiplied by 5. We get the value of moment with respect to point 2, that is 50 into 10 minus 40 into 5. So calculating, we get the moment about point 2 is 300 kilonewton meter. Next, we have to calculate the moment about point 3, that is at this point. So how do you calculate? We have the moment as calculated by VB multiplied by the distance between the 2 points, that is in between point 3 and the reaction force VB, and the distance, so distance is 5, and we have calculated VB as 40 kilonewton. So we have 200 kilonewton meter. We have y1 equals to 0.8 meter, that is the deflection at point 1. And we already know that h into y1 equals to m1, h into y2 as m2, and h into y3 equals to m3, where h is the horizontal, thrust, and we get from the initial calculation as m1 equals to 250 kilonewton meter, m2 equals to 300 kilonewton meter, and m3 equals to 200 kilonewton meter. Putting the value at this equation, that is this equation of y1 and m1, we get value of h, that is the horizontal thrust. That is m1 by y1. So the value of m1, that is 250 kilonewton meter, divided by the value of y1, that is 0.8 meter. We get horizontal thrust H equals to 312.5 kilonewton. So we get H equals to 312.5 kilonewton. Now, putting the value of H at this equation and at this equation, we get the values of y2 and y3, that is deflection at point 2 and at point 3, that is at this point and at this point. So let us put the value of H at the equation. So we have H into y2 equals to m2, and we have y2 equals to m2 by h. m2 equals to 300 kilonewton meter, so 300 by h, that is 312.5. Calculating this, we get y2, that is the deflection under point 2, is, that is under load 30 kilonewton, the deflection of the point 2 is 0.96 meter. Same, we get the deflection at point 3 under load 20 kilonewton. We get m3 by h. m3 we have this, that is 200 kilonewton meter divided by h, that is 312.5. we have 0.64 meter. So at point 1, the deflection is 0.8 meter as given in the numerical problem, and upon calculation we get the deflection at point 2, which is 0.96 meter, and at point 3 the deflection is 0.64 meter. So as per the calculation, we get the deflection pattern of the cable. It's something like this. So as from the problem, we know that the light cable, that is the cable, is supported between 2 points, that is between A and B, which is 20 meter long. The distance between A and B is 20 meter, and the loads are here 5 meters apart from each other, and because of the deflection, the deflected pattern of the cable, it becomes something like this. We know y1 equals to 0.8 meter, y2 is 0.96 meter, and y3 is 0.64 meter. So because of the deflection at 3 points, that is at point 1, at point 2, and at point 3, the deflection patterns is something like this. So after deflection, the deflection pattern of the cable becomes something like this. So from here to here, this is y1, that is the deflection under at point 1, and this is the deflection y2, that is at point 2, and this is deflection at point 3, that is y3. And so y1 equals to this, y2 this, and y3 this. And here you can see the, so this is the segment A1, this is segment A1, and the inclination of segment A1 is, we take theta 1, and the inclination of segment 1 2, that is, this is the segment 1 2, and the inclination of segment 1 2, that is from here and here, the inclination we take as theta 2. Then comes the segment 2 and 3, that is the inclination of segment 2, that is from here to segment 3, and the inclination of segment 2 3, that is, this is the segment 2 3, and the at its inclination is, we take as theta 3, and the segment of 3, that is this, and segment B, that is the segment 3B, and its inclination is, we take theta 4. We have already understood that this is the inclination of A1 segment is theta 1, and the inclination of segment 1 2 is theta 2, and inclination of 2 3 is theta 3 and inclination of 3b is theta 4. Now we have to calculate the values of theta 1, theta 2, theta 4 and theta 3 and theta 4. So in order to calculate, applying the geometry, we have theta 1 equals to tan inverse y1 by 5, that is, if this is base, and this is height, so height by base, as per the trigonometry we have tan theta, so theta 1 equals to tan inverse y1 by 5. So calculating this, we have 9.09 degree, and then you can see that as per the geometry, this angle and this angle are same, that is theta 1, and to calculate theta 2 we have tan inverse y2 minus y1 by 5. So how we are getting this? If this is the triangle that we are considering, then this one is y2 minus y1, and if this is the height and if this is the base, so solving this we have this equation, and from this we get the value of theta 2, that is tan inverse y2 is, we have calculated 0.96 minus 0.8 divided by 5, and we get 1.1833 degree. The same applies to the for theta 3. So how do we calculate? Let us first identify the triangle, that is this one. In order to calculate the value of theta 3, we are taking this triangle into calculation. So what is the value of this? This is the value of y2 minus y3, and we have theta 3 equals to tan inverse y2 minus y3 by 5. So 5 is the base and this is the height of the triangle. So calculating this, we get tan inverse y2 is 0.96 minus 0.64 or divided by 5. So we get theta 3 equals to 3.6 degree. And now if we consider this particular triangle, we will get the value of theta 4. So theta 4 equals to tan inverse y3 by 5, where y3 is the height of this triangle, that is the deflection of this point this. So as per this triangle, we have y3 as height and 5 meter as base. So tan inverse y3 by 5 gives us the value of theta 4. That is the inclination of segment 3B. So tan inverse value of y3 is 0.64 meter by 5. Calculating this, we get the value of theta 4 is 7.294 degree. So because of the application of load, tension appears at the cable. So let us take the tension T1 which appears at the segment A1. That is, this is the segment A1 from here to here. And let us take tension T2 at segment 1, 2. That is between this point and this point. This is the segment 1 and 2. This is the segment 1 and 2. Now let us take the tension T3 which is acting at the segment 2, 3. That means this is segment 2, this is point 2 and this is point 3. So T3 appears at this segment, that is the segment 2, 3. And for segment 3B, that is from here to here, that is segment 3B, the tension is T4. So T4 is acting at segment 3B, that is this section. We have to calculate the values of T1 T2, T3, T4. So in order to calculate the values of this tension, we have to apply Lami's theorem. So applying Lami's theorem at point 1, that is this point, and at point 3, we get T1 minus sine 90 by theta 2 equals to T2 by sine 90 plus theta 1 equals to 40 by 40 means this 40 by sine 180 minus theta 1 plus theta 2. So putting the values of theta 1 and theta 2 in this equation, we get T1 as 316.49 kilonewton and T2 equals to 312.679 kilonewton. From consideration of equilibrium at point 3, that means we are talking about this point, that is point 3, we have T3 by sine 90 plus theta 4 equals to T4 by sine 90 minus theta 3 equals to 20 by sine 180 plus theta 3 minus theta 4. So using this equation, we get, and putting the value of theta 3 and theta 4, we get T3 equals to 313.162 kilonewton and T4 equals to 315.072 kilonewton. So as you can see, we have calculated the tensions that is acting at the cable because of the application of the loads. Now we have to calculate the total length of the cable. Total length of the cable. And what is this? This is the summation of this this, this, and this. So we have to calculate the length of each segment, that is this, 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 and this. So in order to calculate this, we have to apply the calculation of simple trigonometry. So for the calculation of this portion, that is this portion, and we know that this is θ1. So taking the triangle, this triangle, into calculation, we have the length of segment A1, that is this is A1 segment. From here to here, this is A1 segment. So if we take the length of a segment as L1, so this is L1, and L1 equals to 5 into sec θ1, using the trigonometrical concept of this triangle. So we have this calculation, that is 5 sec θ1, and putting the value of θ1 as 9.09 degree, we can calculate L1. Applying the same principles, we have L2, that is L2 is from here to here. This is this length. That is the length of the segment 1, 2. So L2 becomes 5 sec θ2, and then the length of segment 2, 3, and we take this length as L3. So L3 is calculated using the same trigonometrical concept and the concept of triangle. We get 5 sec θ3, and we take the length of this section from here to here, which is L4. There is a length of segment 3 and B. So length of the segment 3B is, we get, applying the concept of trigonometry and triangle, we get 5 sec θ4. So in each case, putting the values of θ2, θ3, and θ4, we get the total length of the cable as 20.117 meter. So again, I am reminding that L1 is the length of segment A1, This is 1, this is 2, this is 3, and this is B. So L1 is the length of segment A1, and L2 is the length of segment 1, 2, 1, 2, and L3 is the length of segment 2, 3, and L4 is the length of segment 3B. So summing up L1, L2, L3, L4, we get the total length of the cable equals to 20.117 meter. So this is the end of our lecture. Thank you.